Welcome to the design project 3. So going to run the program, and then it will prompt you that you need to put in the depth as well as the length. We have it set up so that if you put, say, a length of 3 and a depth of 3, this won't work because the minimum depth is 3.5 and the maximum is 6.5. So if we, for example, put depth of, say, 7 and length of 200, it will still throw an error. It will also do this if you put in negative values for length or depth and things like that. So if you actually put in something proper, say length of 61, which is actually, so we also calculated it. So if you put length of, say, 55, depth of 3.5, we calculated it, we set it up and calculated so that it will throw an error saying, hey, the minimum length with that thickness is 60.002 inches. Length given is too low. This is so that you can't put the improper things in. So length equals 61, depth equals 3.5. We also set the TK and TL to be a bit lower, so it's not as strong. So right now we've got the axis that goes, and if we mess with it over here, it will offset there, so there is a velocity ripple when you mess with that. They are geared together. So it will come back and then start. For the fastest speed, the saw is always in motion, and we set it up because that's most important. And then for slower speeds, it'll pause a bit at the end, and we'll show that in just a bit. So here we have this, and then we have the LED, which it's kind of hard to see, but it does light up at about 1 second. So that's it aligning and catching up. That's it cutting. So what it's doing is the first second is it's catching up to the spot and just moving with it so that there isn't necessarily a speed change. And then for the second, once 1 second is passed, the light will turn on and it starts cutting. We have it set up so that then on its return, it's basically always in motion. Then the next setup is that if we can actually change the length mid-program, so we're going to change it to, say, 200. So it'll still go, but then it's now it's going back much slower. It is still cutting for the same depth. There is the pause because it is set up so that at the minimum length it can go, it will basically come back immediately. But for when it's coming back, when it has a longer to wait, it does come back slower. We did try multiple calculations and multiple methods in order to have the comeback speed be proper. However, there were always issues where it wouldn't come back fast enough for the fastest speed. This could be fixed by having a higher speed motor, a motor with a high enough torque and a higher speed. We kind of ran into speed caps on getting that torque properly. Then we can change the depth to be 5, and we'll change the length to be shorter so we're not waiting as long. So, for example, earlier we couldn't do a length of 50, and now with the depth of 5, which does travel slower, we can. If you'll notice that it comes back sooner because it is going less distance because it's not going as fast. But there's still minimal pausing at the end. In terms of position and error, the maximum error per tolerance of 10 thou is around 300 and is more than 350 off count. All of our errors so far are usually running less than 100, so it meets that tolerance. Here is the velocity accuracy. The velocity between A and B is directly correlated as they are geared. And it is displaying the velocity for when it is cutting. So for the first part where it's just catching up, it isn't displaying, but for when it is cutting, it does, for the awesome LED over there. And then, I guess, show it when it's actually on. There you go. Then we have the off switch. And this is intended and does basically set it up so it deaccelerates and then it disables the amplifier. So click and then it's off.